Okay. So let me start that again so I can cut this bit out. So, okay, because I've started recording now, so we'll start here. So imagine you have sets A, which are 1, 2, 3, this set here, and set B, which is 7, 8, 9, which is here. And you notice how the numbers are all different. So that means that the circles are not touching. So in this case, later on, you'll learn about disjoint sets. Oops, admit. So disjoint sets. That means they're not touching. Disjoint means not joined. So not joined. But we're going to look more at these a little bit later when we do some calculations. So they show no overlap. No overlap, they don't touch. So the circles don't touch each other in this case. In 2, we have some sets that will partially overlap. Okay, so this circle and this circle are touching because you've got CE in this set and you have CE in this set. Okay, so those 2 letters, CE, go in the middle because they're shared between both circles. So set A is actually all of this. So that's set A, including C and E, right? That's set A. Set B has C and E, but it also has B and F. So they're written in this part because they're not in A. So set B would be written like that. Okay, so they have a partial overlap. Okay, and this is the common one that you see in a lot of questions where some elements are shared between the 2 sets. In question, well, part 3, notice how we've got sets that completely overlap. This is another situation you'll find in the book. So set A is OPQRS. OPQRS. Set A means all of these elements here, including the ones that are in B. Okay, so those red lines represent set A, everything. Set B is PRQ. All of those elements are in here, PRQ. Remember, we say that is B is a subset of A. Remember subsets? So that's what you have there, a subset. So you're going to see this kind of question as well later on. So those are the 3 kinds of sets you'll see. I should scroll with the hand because it's easier. Okay, so these are some concept, and I'm going to go fairly quickly because there's not many questions in this section. Okay, so we've got universal set and complement of a set. Now, the universal set is a set which contains all of the elements under consideration, everything you are interested in. So that could be all of the students in grade 10. That would be a universe. Or it could be all the students in the high school, like that. And the symbol we use is epsilon, that's a Greek letter, or just a capital U, like that. And the sets may be infinite or finite. So as an example, an infinite set could be, remember, the even numbers, the set of even numbers. So that could be your universe. So we would write that as like that. You know, like X such that X is an even number. Who's got their mic on? Okay, so that would be the way you could write the universe. And they can be infinite or finite. Like I said, the number of students, or I should say the students in grade 10, like that. So that would be a finite set because we can count them all. All right. So let's look at an example. Okay, example 19. It's 19 because it's going on from section 1, which I didn't give to you. That was when we did by video. Okay, so here's a universal set. It could be the numbers 1 to 10. Okay, where set A consists of the natural numbers, where set A consists of the natural numbers between 4 and 7. So this is your set A here, and the natural numbers, so that should be inclusive. Yes, inclusive. So including 4 and 7. So that would be 4, 5, 6, 7. But here you said the universe is 1 to 10. Okay, so that is all the numbers in the universe. You see how I wrote that there? So your universe is here. This is your universe in green, all the numbers. And set A are your natural numbers between 4 and 7 inclusive. So what we've got written here is this symbol. You see what I've written here? This is complement of A. So what you've got, set A is 4, 5, 6, 7. So that symbol means complement of A. It means not A. It means not in A. Or in the book, it says complement down here. See that? Complement of a set. So complement of A. So that symbol is written as a dash here. I'll draw that with the highlighter there. So this means not A. So what that means is that the number is X that is in the universe and it's not in A. Okay, so if we were to write the elements out, so which elements are not in A, but they're in the universe? You see, they're in the universe and they're not in A. So that means all the other numbers. So 1, 2, 3, 8, 9, 10, which I've written down there. So 1, 2, 3, 8, 9, 10. So all the numbers that are not in A. And what you'll notice is that we'll come further down because I've made it really large for you to read. So what you notice here then is that, okay, not A, 1, 2, 3, 8, 9, 10. And note this here, the number in the universe is 10. The number in A is 4. And the number of elements in not A is 6, right? 1, 2, 3, 4, 5, 6. And the number in A are 1, 2, 3, 4 up here. So this is one property of complementary sets, that the number in the universe is the sum. The number in the set A plus the number that is not in set A, always. Okay, so that means when we put them in to check, we can check them here. So the number in the universe is 10. We got that from the question. The number in A is 4. The number not in A is 6. And they should be equal, always. So that's one way you can check that you've done the work correctly here. So how about this question? You want to look at it yourself for a bit? So let's see what we got. Oh, also, I forgot to tell you, in some book, they use AC, especially in Thai books. And that means the same as not A here. Okay, that means complement of A. They put C on. But not in many of my books, they don't use C. They use A prime like this. But it means the same thing. So if you use a Thai textbook to review, then you will see that written as C. Okay. Okay, so I'll help you with the first one, then you see if you can do the others. Maybe a number line will help here when you do these. So when you get your worksheet, I'll follow similarly to these questions. Okay, here's your universe. These are all the integers. Okay, all the integers, positive and negative. So you could draw that like that. So this is your universe, okay? And here it says set A is numbers greater than 5 that are integers. So if you put 0 here and 5 is here, so greater than 5 is here, right? Any number more than 5. So we use an open circle because we don't include 5. So this is set A. Does anyone know what is the complement of A? Sorry, set A, not complement. Let's erase that. That's set A. Say one thing and write another. Okay, so this is set A here. That goes to positive infinity. So if that's set A, what is not A? So where is complement A? Can anyone tell me? No one know? So you're either in A or not in A, right? So if you're in A, you would be here, yes? All numbers in A going that way. So where is not A? If this is A, isn't not A in the other direction? This would be not A here. Because you're either in A or not in A. You can't be anywhere else. And your universe is all the integers along here. So that means you would write not A is X such that, now this is greater than 5. So that means not A must be less than or equal to 5 in this direction. And when you add them up, you'll get all of the integers. So this is A going to positive infinity. Not A will go to negative infinity in that direction. So not A, X would be X is less than or equal to, because this doesn't include 5. So in not A, you must include 5 going that way. So that would be less than or equal to 5, and X is an integer. Is that okay? Yes or no? Don't know. So I'm going to leave you a few minutes. I want you to try the other ones here. So B, C, D. I'll help you and say maybe 5 minutes or so. Do you want to have a try yourself? Maybe a number line will help. So this is all real numbers, all rational numbers. But you can still make a number line. Well, that's really bad. So try to draw your line a bit more like an actual line. It's got this on here. I could probably use that. All right. So make a number line. And I'll do one for that one. Question D, you don't need a number line. We won't need that. Okay, I'll give you a couple of minutes. Can you try and do that exercise? All right, I'll give you a few minutes and I'll come back in a minute. So this is your classwork. So I'm not going to mark this, but you'll get a worksheet. I don't know, maybe next week sometime, but not yet, because we still have quite a bit to do here. So have a go at that for a minute. But question D, you don't need a number line. So this is your real numbers. So that's your universe of real number. And this is your universe of rational numbers. But we can use number lines, right? So I'll come back in a minute. So find the complement. If anyone finished, just call out the 3 questions. So if you're done, question B, start marking out where set A is. Okay, I don't use Venn diagrams for these because you're using real numbers. And also the first one is an infinite set. So you wouldn't try to solve these ones using a Venn diagram because you just can't do it because you're dealing with real numbers and infinite sets. So whenever you see real number and rational number, think about a number line. So in this question, it says that A is X is greater than 2. So that's about here. X is greater than 2, or X is less than 0, which is, say, there. Okay, so this is set A, and A go to infinity, right? So this is going to go to infinity, and so is this. And that's set A. All right, that's set A. So set A, what bit is missing? You can see it's the bit in the middle here. So this must be not A. So you're either in A or you're not in A. You're in 10B or you're not in 10B. You're nowhere else. It's either one place or another. So in this case, 0 is not included in A, but that means we need to include it in not A. So that would be all the numbers between 0 and 2, and that's not A, complement A. All right, so the way you would write that would be not A is, now that's between 0 and 2. So we're using the notation we learned in polynomials. So between 0, X and 2, and state the kind of number, X is a real number, like that. Okay, so that's not A. Are you getting it? Hope so. So that means now I've covered all the possibilities. So these are all the real numbers included. Not A is here in yellow, and not A is in green. And that covers all your possibilities of numbers. All right, so for C, even though it's rational, that's all, any number that can be written as a fraction. So this would be an infinite set anyway. So we'll just use a number line again. So here it says A, X is less than 1. So 1 is here, and less than. So use an open circle. That's less than 1. Or X is greater than or equal to 5. So 5 is here. But now we need to close the circle because we are including 5 in the set for A. So that's set A. I'll put in yellow. Right, that's set A. Okay, set A. So again, set B is the stuff that's missing in here. So set B, I'll do it down here. So set A doesn't include 1, but that means you must include 1 into set B because you need to cover all numbers. So if 1's an open circle, this one should be a closed circle. Then go up to 5. This is closed, so this must be open. And this would be not A. So we'll do that in green. There. Okay, so set A, well, not A. Set not A will be X is between 0 and 5. So X such that X is between 0, 1, sorry, it looks like 0, 1. So between 1 and 5, rather. So between 1, but now you must include it. And up until 5 there. These answers are in the back of the book. You see there's an answer key in the back, right? So you can check this and check my working too. What about the last one? D. We've got 4 kinds of animals: sheep, goats, dogs, fish, snails. And A are all 4-legged animals. And this is your universe. So you can't mention any other animals. So if 4-legged animals are which? Sheep, goats, and dogs. So these are your 4-legged animals from the universe. So obviously your ones that are not are fish and snails. So they're the animals that are not. You see, I didn't mention any other animals because our universe is only these 5 animals here. You can't say elephants and stuff like that because it's not in the universe. So only stuff in the universe. So that's going to be fish and snails. And that could be done as a Venn diagram. So if we were doing a Venn diagram, you would have set A, which is sheep, goats, dogs. So this is set A. So we'd have sheep, goats, and dogs in here, and fish and snails would be outside the set, like that. And so the universe is all of those animals in here. That's your universe. Okay, so that one you could use a Venn diagram because we have elements and we have a finite set too. So no problem with that. Any questions yet? We're all very quiet. Oh, so let's see how we go. We've got about 20 minutes. How about this one here? Hi, but use the panning hand. Okay, question 2. So what do you think here? You could think about Venn diagrams if you want. So in the first one, the number in the universe is 13. This means 13 elements. And remember our little formula, the number in the universe is the number in P plus the number not in P. And when you're doing Q, same idea. The number in the universe, the number in Q, plus the number that are not in Q. So these cover everything that's in the universe. So in this case, I'll do first one for you, then you can try these other ones. So what is the number in the universe is 13. So let's write your formula. Equals the number in P plus the number not in P, like that. The number in the universe is 13. So we write 13 here. The number in P is 7 plus the number not in P. So how many are not in P? Isn't that 13 minus 7, isn't it? What's that? 7 plus 6. So that should be equal to 6. There, that's the answer for that one. So you try that one using this formula here. Okay, I'll give you 5 minutes. Think about these ones here. Are they true or false? And you may want a diagram to help do them as well. So I'll leave that there if you're copying it. So try B and then try question 3 here. I'll give you a few minutes. We got 20 minutes, so I might look at the next section as well. So take a look at that for 5 minutes. In question, well, I guess you're doing B, so I won't jump ahead. So just use your formula, the number in Q. I guess you need to see it there. So the number in the universe is 13. So we would have 13 down here. Not Q is 3. So the number in Q, which you want, and the number not in Q is 3. There are 3 elements not in Q. So just bring your 3 over. So the number that are not in Q will be 10. Okay, so you can use the Venn diagram to help with that work as well if you want, but you can just use this formula here, these 2 formulas. Okay, and these work for any kind of question. Now for this one here, okay, you got number in universe, number in A, number not in A. I want to know if this is true or false. So what you're doing, you're checking this bit here, if this is going to be true or false. So I'll scroll up a bit. So again, you can write your equation out. The number in the universe is the number in A plus the number that is not in A, the number of elements. So in this case, the number in the universe is A. The number in A is B plus the number not in A. So the number not in A is what? You would bring your B to the other side, you'll get A minus B. But this says B minus A. So that's wrong. This is the correct answer here. It should be A minus B. So this is false in that case. Okay, so I'm just referring back to this solution here. How about B? You may want to think about a subset here. Let's make it a Venn diagram for doing this one, because I don't have any numbers to work with or anything. So Q is a subset of the universe. So this is your universe, this rectangle. Set Q is a subset. So I'll put Q inside here. So I want to know if this statement is true or false. Anyone? You got a 50% chance of being right because it's only true or false. So this is saying an element X such that you're not in Q, but you're in the universe. That is Q naught. Q naught is out here. So is that right? You're not in Q, but you're in the universe. That's what that says. Not an element of Q, but you're a member of the element of the universe. So that's going to be true. That's this area here. So for that answer, you'll be true for that one. We're assuming that not Q is within that universe. Okay. So the number in the universe, we're assuming that the number in the universe is the number in Q plus the number not in Q. Yeah, you might have to use this formula a lot, but you'll come across it when we're doing the next section. So actually in the next section, I can talk about it a bit, which is about that's gone too far. That's intersection. We're going to do union. Hold on. Yeah, it's intersection. All right. Part C. So we can start this today and do a bit more tomorrow. Now, intersection should make sense because they're where sets are going to touch, intersection. That's this part here. So any element that is written in here is in the intersection. And the symbol we use is an upside down U. A intersect B. Where does A touch B? So this is very common. You're going to have to learn this notation here. So formally, it says that X is an element of A and an element of B. It means it's in both A and B. In both. So X is in both A and B. So it's in both sets. So in the example we have down here, Oops. Panning. There. So I've actually given the whole solution because I didn't want to have to redraw all of this because I think it's quite slow. So I need to change the view down a little bit. Maybe like that, a bit more. Okay, I hope you can read that all right. So you've got a set here. Let's see how this example works. And you can do some more tomorrow. So we've got a universe. Actually, I'm missing universe. That's the universe 1 to 10. Set A is 1, 2, 3, 6, 7. Set B is 2, 3, 8, 10. So we have a square. So I didn't write that. That's your universe. Everything inside this rectangle is the universe, 1 to 10. Now look at set A. Set A is 1, 2, 3, 6, 7. 1, 2, 3, 6, 7 in set A. But notice how 2 and 3 are in both. You see they're in both sets. So those two numbers have to be written in the middle here because these are the shared elements. They're in A, but they're also in B. Okay. And set B has 8 and 10 left here. All right. So your intersection is only that bit that's in the middle here, 2 and 3. We'll see that in a minute. So the first question is, the answer's down here, but we'll do a bit of working here. Find the complementary set, not A. So this is A here. All of that there. I'm going to rub this out later. But this is set A. But I want to know what is not A. So which numbers are still written outside of A? 4, 5, 8, 9, 10. You see down here, 4, 5, 8, 9, 10. So these are the elements that are not in A. The answer's down there, 4, 5, 8, 9, 10. And when you want to do not B, you do the opposite to that. So set B is here, correct? That's set B. So which elements are not in B? These ones here. 1, 6, 7, 5, 9. Why? Oh, and 4. I missed 4. So these are the elements that are not in B. So look at B and then look outside of B, including the ones outside of A. So not B means anything that's not in B. All right, so that's your complement of the set. We got 10 minutes, so I may explain a bit and we can work more tomorrow. Now, A intersect B. A touching B. So A intersect B are only these two elements here. These are the ones that are shared with both sets. Okay, now this one, D and E, oh, we could do F, the cardinal number, the number of elements in the intersection, 2. That's that number there, 2. So we can do F, okay. But for D and E, we probably need to think about the Venn diagram a bit when we do D and E. And Venn diagram is a really big thing for this topic. So let's make a Venn diagram. So A intersect not B. So I'm going to draw that again, but without the numbers. So we want A intersecting not B. So now we need to learn how to shade in the diagram a bit. This is set A, this is set B. So A touching not B. This symbol here, we are looking for this. And I'll show you what that means in a minute. So A, so the first thing you do, we shade in A here. A there. Now we'll shade in B. We'll use a different color. We'll use blue. And I'll put my lines in another direction. Oh, but this says not B, also not B. So color in everything that is not B. Not B, don't go in B, illegal. So don't go in B. We're going to do a lot of this, so don't worry about today if you're not getting it. You're going to do more tomorrow. So that is not B that I've colored in blue here. Now, where do these two touch? Look for this. You can see that it's only going to be in this part here. I'll use the highlighter. So only this area here. So that's A touching not B, which is here on our diagram. So that's 167. So tomorrow we'll spend a bit more time on the Venn diagrams as well. So that's 167. And similarly, if you did A, not A touching B, let's do it again. Not A intersecting B. So you make a Venn diagram. I'll leave them here if you want to draw them. A touching not B. Sorry, not A. Not A touching B. So not A. And this is A here. So not A. So you go around A. Don't touch A. So not A touching B. Now B, use a different color if you like. If you have a tablet, quite useful. So color in B like that. So because it's intersection, we want to know where they're crossing over. So we're looking for this here. And that's only going to be in this part here. So color in that area there. So that's not A intersecting B. And that would be these two numbers here, you see, 8 and 10 there. So you get 8 and 10 for that. And we did F already. Okay, so I'll scroll down a bit. And I'll review this tomorrow anyway, a little bit. So basically like that. Well, here's another example. Now, we've got 4 minutes, so I'll go through it fairly quickly and we'll do it again tomorrow. So your universe are natural numbers 1 to 20. All of the numbers are in here, 1 to 20. A is 1, 2, 3, 5, 6, 7, 8, 14, 18, like that. But what we should look at a little bit, look at 6 and 7 here. 6 and 7 is in the middle. That means they're in all three sets. So 6, 7, 6, 7, 6, 7. Okay. And they're in all three sets. So they have to go in the middle because that middle bit is the sharing of all the three sets. So A, B, C. So 6 and 7 have to be in the middle. Look at number 1. See, 1 here is in A and B, but it's not in C. Let's look at that. So A is in, 1 is in A, 1 is in B, but it's not in C at all. So it has to go here. So that's shared between A and B, but not in C. If you look at 2, 3, 14, they are in A only. So A only. So let's look for them. So how about A only? 2, 3, and 14. 2, 3, and 14. They are not in these sets at all. You see, when you look for them, they're not here. So that means they're in A only, 2, 3, and 14 in that section. And the same for all the other numbers here. So the point is, if you can finish your Venn diagram, if you can fill in this Venn diagram, like shown in the example here, you'll be able to answer all of these problems, all right? but I'll go through that again tomorrow a bit more fully. All right, so we had a bit of time to use up, so I figured we just talk about intersection. And we have these examples we'll do tomorrow. So I think we'll do this tomorrow and maybe a few more examples. I won't go to the next section. Okay, so I'm going to leave it there and then we'll come and do these tomorrow. All right. So I'm going to go now and then you can work on your homework sheet. Okay, you've got a homework sheet to do, right? Yeah, you got the sheet to do. So do that and then we'll talk again tomorrow. Okay, about this topic. All right, bye-bye.
Bye.
Thank
All
you,
right, see you
teacher.
later.
Bye bye.
Bye, sir.
Okay, see you later. Bye-bye.